Hello, sixth graders, section 3.2. We're going to take what we already know with the interior angles of a triangle and elaborate on that and do more with it. So what do we want to do this chapter, or this section? The first thing we want to do is verify what we know the difference of in terms of interior and exterior angles of a polygon. Now the angles inside a polygon, represented by here in the red, are interior angles. When the sides of a polygon are extended, other angles are formed. Notice we have a triangle, but we extend those to make exterior angles. Now, exterior is outside, but make sure you understand this definition. The angles outside the polygon that are adjacent to the interior angles, remember what adjacent is. Adjacent is angles that share a common side and vertex. Represented here in blue, these are all exterior angles. This is not an exterior angle. This is not an exterior angle because it is not adjacent, it's vertical. Now the key idea that you already know is that the sum of all of the interior angles add up to 180 degrees in a triangle. Now we're going to take that one step further and we're going to do it algebraically. In this triangle we have three angles: angle X, angle Y, and angle Z. They all have a sum of 180 degrees. Therefore, we can use algebra to represent an equation that represents that. So we're going to start off easy. Find the value of X. Here is a red triangle. Now we know that all three of these add up to 180 degrees. So we could write the equation X plus 80 equals 180 degrees. By subtraction, and by the way, if I asked you the reason, you'd say the interior angle theorem, or you could just say the sum of the interior angle measures of a triangle is 180 degrees. By subtraction property, I subtract 80 on both sides. Therefore, X is going to be 100, which means the angle measure is 100 degrees. In B, I know this angle is 90, so I would take X plus 28 plus 90 equals 180. I combine like terms. 2x plus 118 equals 180. This is all review now. I use subtraction property to subtract 118 on both sides. That gives me 2x equals 62. And by division property, I divide both sides by 2. That gives me x equals 31. So the value of x is 31, which means the angle measure here is 31 degrees. And we could plug 31 in here for x on the second one to find it, but that's not what it's asking. Before we go on to the next concept, I want you to, on your own, find that missing angle. So do it yourself. I'm not going to keep going until you do that. So what did you get? Hopefully you got 74 degrees. But we're going to extend this side. And this angle right here is adjacent to the 74. And we're going to call this Z degrees. So what's that angle measure? Well, we know they're supplementary. So if I take 180 minus 74, that gives me 106. So we know Z is 106. Look at all of your angles and tell me if you notice anything. (81) plus 25 gives me 106. Which actually leads into our next key idea, which is this. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. This angle right here is adjacent to Z. So the two non-adjacent interior angles would be, in this case, XY. So to find the measure of z, we could find the sum of x and y. So z equals x plus y. In example 2, we're going to start down here with a study tip. Each vertex, that means each vertex of the triangle here, has a pair of congruent exterior angles. However, it is common to show only one exterior angle of the vertex. What it means is this. I could actually extend this side as well. Whoops. And that means these two are both x. So this is also x because they're vertical angles. Well, usually we don't show both of them. We only show one of them. So A, what do? X is going to equal the sum of 36 and 72. So x is going to equal 108. Notice this problem. This is one of those geometry things that a lot of students make a mistake on. This is not asking for the value of x. If it asks for the value of x, you would tell me 108. It's asking for the measure of the exterior angle. So the measure of the exterior angle will be 108 degrees. You don't need to put a degrees next to the x because it's already up here in the picture. B, 2a equals the sum of the non-adjacent interior angles, so 80 plus a minus 5. Combine like terms, that would give me a plus 75. By subtraction property, I get the variables on one side by subtracting a. That gives me a equals 75. Notice, by the way, that I am skipping steps that look like this. Minus a, and so on. You should be able to skip those as well. You can still show them, but you should be able to start skipping steps to be more efficient. Now, a equals 75 is not my answer. I want to know the exterior angle. So I take the 75, plug it in, easy. 2 multiplied by 75 gives me 150 degrees. In example 3, an airplane leaves from Miami and travels around the Bermuda Triangle. What is the value of x? Well, by the triangle sum theorem, we know that all three of these angles add up to 180. So I could do 3x and then 62.8 subtracted by 44.8 would give me 18 equals 180. By subtraction property, I get 3x equals 162. And then by division property, I divide by 3, which gives me 54. So the value of x is 54. Not 54 degrees, 54. Now in 8th grade, you're going to start talking about theorems in geometry. But in vocabulary, we need to know interior angles and exterior angles. But I'm actually going to start calling theorems by theorems rather than giving you a name now and then giving you a different name in 8th grade. The triangle sum theorem is knowing that all angles, the interior angles of a triangle, add up to 180.